In today's lesson, we are going to be looking at going from the standard form to the factored form. So this is kind of a reverse of what we've looked at in the previous lesson. We're kind of just going in the opposite. We're going from standard form to factored form. We are going to be using factoring, which we have covered previously. So again, this might be a lot of review, but we are tying it into the quadratics that we are learning about. So we just want to recall simple trinomials. So a simple trinomial is one in the form ax squared plus bx plus c, where a equals 1. So generally we wouldn't see a value in front of the x squared because it would be a 1. So we factor it by finding two integers that multiply to give c and add to give b. So this creates two binomials, each with a variable term and one of the integers that we just found. So let's take a look at two examples. So if I'm looking at x squared minus 5x plus 6, I'm going to use product and sum. So I'm going to look for two values that multiply to give me my last number, or 6, and two numbers, or the same two numbers, have to add to give me my middle number, or negative 5. In this case, the two values would be negative 3 and negative 2. Negative 3 times negative 2 is 6. Negative 3 plus negative 2 is negative 5. Once we find those two values, we plug them into two brackets, x being the first term, which is our variable. We have then minus 3 and minus 2. If I look at the second example, same idea. I'm going to be using product and sum, looking for two values that multiply to give me my last number, or negative 12, and they add to give me my middle number, or in this case, 1. So again, take a second to think about what numbers multiply to negative 12. Again, you can use the multiplication table if you need it. You should have that from a previous lesson, but in this case we should have positive 4 and negative 3, because 4 plus negative 3 is 1, 4 times negative 3 is negative 12. Once we find our two values, they go into our two sets of brackets with x, so one will be plus 4, one will be minus 3. So those are our two factored forms from these standard forms in simple trinomials. If we look at tricky trinomials, so these are the more complicated ones. These are where we have ax squared plus bx plus c, where a does not equal 1. So we do see a visible value in front of the x squared. We factor it by a method of decomposition, which we have talked about. This is exactly the same kind of slide or same description from our review unit. This means that we look for two integers that multiply to give a times c and add to give b. We then split b up into the two numbers and factor by grouping. So we have our two standard forms here. They are tricky trinomials because we see a value in front of the x squared. We're going to take a look at the first one. So 2x squared minus 5x minus 3. We're looking for two values that multiply to give us a times c, or 2 times negative 3, which is negative 6. The same two numbers have to add to give us negative 5, or our middle value. So what two numbers multiply to negative 6 and add to negative 5? In this case, we would have negative 6 times positive 1. Negative 6 plus 1 gives us negative 5, and they multiplies to negative 6. So the difference here is that we take this middle value, so we're still left with the 2x squared. We take this middle value and split it up. So we have minus 6x plus 1x. And minus 3 is still the same. Now we're going to factor by grouping. So I'm going to highlight my first group. And I'm going to factor that. What is a common factor between 2x squared and negative 6x? In this case, 2x is a common factor. Leaves me with x minus 3. And if I look at the second pair, there's nothing I can really factor out of that, so I can just say plus. If I want to put it in brackets, because it is one whole term, maybe I factor out a positive 1, which doesn't change anything anyways, x minus 3. We should then recognize that we have two brackets that are the exact same in both terms. I can then factor by grouping. So I take x minus 3 out, and then the leftovers 2x plus 1 is the remaining bracket. So that's factoring a complex or tricky trinomial. A little bit different, same kind of beginning, but a little bit different at the end. If we look at the next example, same idea. We're looking for two values that multiply to give us the first value multiplied by the last value, or in this case 7 times 4, which is 28. And they must also add to the middle value, or 29. So what two numbers multiply to 28 and add to 29? This one is relatively straightforward. It's 28 times 1, because 28 plus 1 gives us 29. So now, again, we take our two values, we break up that middle term. So the 7x squared stays the same. This 29x becomes 28x plus 28x plus 1x. The 7x squared and the 4 do not change. We now factor by grouping. So I take my first two terms, my last two terms, and I factor them. We're going to common factor. So I can factor out a 7x in the first one. I'm left with x plus 4. And the second one, again, there's nothing else I can really factor. I could factor out a 1 maybe, just so I can put the second part into brackets. I should find that I have the brackets that are in common. I can factor those out. X plus 4 comes out. What's left over, 7x plus 1, is the second bracket. So those are two ways to factor, or those are two different scenarios that we come across where we have to factor either simple trinomials or complex trinomials. Hopefully these trinomials look very similar to the standard form of an equation, which it is, essentially, except without the y equals. So this is how we're going to be going from the factored form of a quadratic to the standard form. So again, we just mentioned it. To go from standard form to factored form, we can use factoring to change the standard form to the factored form to find different characteristics of our parabolas. So again, we mentioned at the very beginning looking at the different types of quadratic formulas or the quadratic equations, that each type has its own kind of characteristics that it can tell you directly from the equation. Factored form was very useful. Standard form, not so much. It did give us one piece of information, but factored form did truly give us, or allowed us to find everything. So it is helpful to go back and be able to convert between them. So we're going to go kind of step by step. So we have our parabola with an equation y equals 2x squared minus 4x minus 6. What is the y-intercept of this quadratic? Well, this is the one piece of information that this quadratic gives us, which is this last value, that minus 6. So that minus 6 is our last value. That's our y-intercept. We want to factor the equation and write it in standard form. So in this case, I want to factor 2x squared minus 4x minus 6. So I want to factor that and write it in factored form. Now there is something useful about this one. I can take a common factor of 2 out from the beginning. So if I take that common factor of 2, it does make my equation a lot simpler to work with. So in this case, we have a simple trinomial inside the brackets. So I'm looking for two values that multiply to give me -3, but they add to give me -2. So in this case, my two values would be -3 and 1. Because -3 plus 1 is -2. -3 times 1 is -3. So that means my two brackets, x is the variable term in both. 1 is -3 and 1 is +1. I now have my equation in factored form. If I want to be specific, I can say y equals 2 times x minus 3 times x plus 1. That's my full factored form. And I can pick out the zeros from this. I can find what the zeros are because we've mentioned that the zeros are in the brackets. They're the opposite of what we see. So instead of -3, it's +3. And instead of +1, it's -1. So we do have our two x-intercepts. From there, we can then find the axis of symmetry. So the axis of symmetry, in this case, we add our two zeros, so 3 plus -1 and divide by 2. So we get 2 divided by 2, which gives us 1. So our axis of symmetry is 1. We can then determine the max or min value by plugging that axis of symmetry back into the equation and solving. Now technically in this case we have two different equations. We have the factored form that we found and we have the standard form that we started with. You can choose to use either one. It's essentially the same. It's the same quadratic, just a different formula. I'm going to use the first one. It's a little bit easier to work with, less calculations. So y equals 2x squared, I'm just going to go back, minus 4x minus 6. The axis of symmetry we found was 1, so I'm going to go through and plug in 1 everywhere I see an x. So 2 times 1 squared minus 4 times 1 minus 6. I can just go through and calculate. So 2 times 1 is 2 minus 4 minus 6. I get y equals 2 minus 4 is -2, minus 6 is -8. So I now know that the optimal value is -8. I could also say that it is the maximum value, or not the maximum, the minimum value. And I know this because the a value of my equation is positive. So that means it opens up, which means I have a minimum. For the step pattern, the a value we get from our equation, we see that twice. We see it here as a 2, and we also see it here as a 2. So my a value is 2. This means then that what I can do with that general form 1a, 3a, 5a for the step pattern, 1 times 2, 3 times 2, 5 times 2. So my step pattern then would be 2, 6, 10. And that's going to help me for when I go through and I graph my parabola, which I'm going to do. So I'm going to graph it using all the information. I have my x-intercepts. They are 3 and -1. So I can put points at 3 and -1. I do have my vertex because I know the axis of symmetry is 1. So I know that there's going to be my vertex somewhere on this line. Just draw a straight line down. And I know where it's going to be specifically because I found the minimum value, which is -8. So I know I'm going to have a point here. So I know my vertex. Now, we could kind of go through and just sketch it out, but we do know the step pattern. So the step pattern tells us I go over 1, up 2, and there's a new point. It also tells me that I go over 1 again, and up 6 to my next point, which does work because that lands us exactly at our x-intercept. I can repeat that on the other side, or just mirror the points. It does also match that I do have a y-intercept of -6. So I'm going to roughly draw it out, if I can keep a steady hand, which it doesn't seem like I can. And again, I wouldn't expect the same from you, as long as you can roughly sketch it, get the general shape. Obviously, it extends beyond those x-intercepts, so we can put some arrows on the end. So I have my parabola now. I can also write it in vertex form if I really want. So if we recall back to when we introduced quadratics, vertex form ax minus h squared plus k. We know the a value is 2. It's the same as the other ones. We also know the h value, which is the axis of symmetry, or in this case, 1. We put the opposite in, so -1. And the k value is that optimal value, or -8. Okay, so we have our a value. We have our h value. Or not the h value. We know it's the h because it's an h. We say the axis of symmetry. And here we have the optimal value. So realistically, we can go now from standard form to factored form to vertex form. We just learned how to go from standard form to factored form. Well, we already knew how to do that. We just kind of reinforced that, or made the connection between what we were doing. And we've previously learned how to go from factored form to find the vertex, find the axis of symmetry, find the optimal value, and be able to graph it, which we can then also pick up or create the vertex form, which we have here. So we're just going to go through one more example. I'm going to challenge you to try to do this on your own. You can maybe at least up until the graphing part if you don't have a grid, but we have an equation here, and we want to basically go through the same steps, factor it, turn it into factored form, go through the steps of finding all the information that we can from factored form, vertex, axis of symmetry, optimal value, and then write it out in the vertex form. If you don't have grid paper to graph it, that's okay, but I do challenge you to go through the exact same steps that we just did, and try to convert this standard form into the other forms. All right, so again, I recommend that you pause the video, and we'll come back with our answer. So coming back, we should find that the y-intercept, again, is that last value, that c value, or 15. If we want to factor this, it works out to be a simple trinomial. So two numbers that multiply to 15 and add to 8. We should find that it's 5 and 3. That means when we can plug it into our factored form. Oh, I kind of missed writing out the full factored form. So x plus 5 times x plus 3. Right? Adding that y equals in there does make it an equation. So when we talk about writing it at the equation in a specific form, we do want to have the y equals part. So -5 and -3, because it's the opposite of what we see in the equation. So in the equation we see positive, so here we see it's actually minus. Our axis of symmetry, we add those values up, divide by 2. We end up with an axis of symmetry, AOS, equal to -4. We can plug that value back in to our equation. I plugged it back into the original standard form, find it a little bit easier to use, and we get a value of -1. So this means that my optimal value is -1, and I do know that it is a minimum again because my a value is positive. So that means it's opening up. For the step pattern, I'm going to use that a value. In this case, because the a value is 1, I plug it into that general formula, 1a, 3a, 5a, and just get 1, 3, 5. Oops. I can then graph my parabola. Right? I have my vertex, which I know is at -4 and -1. I have my 2x intercepts. I can use the step pattern, go over 1, over 1, up 3, over 1, up 5. I can also graph my y-intercept, which I would see would be the next point over, and then I can mirror that entire image onto the other side. Right, so really I only need to use the step pattern to find one side or one half of my parabola, and then I mirror it to the other side because of that axis of symmetry that goes down the middle. I can then write it in vertex form, y equals a, which is 1, in brackets x plus 4, opposite of what we see for this axis of symmetry. So instead of it being -4, it's actually, in our equation, it's +4 squared, and then -1, which is our k value, or that optimal value. So again, the main thing from this is that we understand or how to factor. We have already reviewed factoring, so hopefully now we're still a little bit comfortable with it. And then using that factoring, we can convert between different forms of our equation. We can go from standard form back to factored form, which we can then go through, find our key characteristics by doing some small calculations, and then we can actually even write out our vertex form from that. Right? So again, the idea is just all about making connections between the different forms and how we can convert freely between them.